What if I told you that we're on the verge of harnessing the very power that fuels the stars, right here on Earth? It sounds like science fiction, doesn't it? But at the Lawrence Livermore National Laboratory in California, scientists have just taken a monumental step forward in America's quest to build an artificial sun. They've achieved fusion ignition, a process where a nuclear fusion reaction produces more energy than it consumes. This isn't just another scientific milestone. It's a profound moment in human history, a tiny spark that could ignite a revolution in how we power our world. For decades, the dream of fusion energy has been just that, a dream. It's the ultimate cosmic power source, the same engine that makes our sun shine, promising a future of limitless carbon-free energy. Imagine a world where our cities are powered not by burning fossil fuels that warm our planet, but by tiny man-made stars. A world where energy is abundant, clean, and safe, derived from the most common element in the universe, hydrogen. This recent breakthrough isn't the final solution, not yet, but it's a powerful declaration that this future is no longer confined to the pages of novels or the silver screen. It's becoming our reality. So what does this mean for you, for me, for all of us? It means hope. It means we're cracking the cosmic code to solve one of humanity's greatest challenges. Join me as we explore this incredible achievement and other mind-bending energy innovations from around the globe. We'll journey from the heart of an artificial star to massive wind farms, deep underground energy vaults, and even to the far reaches of space, all in the quest for a sustainable future. Let's get started. So let's break down this artificial sun. At its core, the goal is nuclear fusion. Unlike fission, which powers our current nuclear plants by splitting heavy atoms apart, fusion does the opposite. It takes light elements like isotopes of hydrogen called deuterium and tritium, and under immense pressure and temperature, hotter than the core of the actual sun, it fuses them together. When they combine, they form a heavier element, helium, and in the process, a tiny fraction of their mass is converted into a tremendous amount of energy. It's Einstein's E equals mc squared in its most elegant and powerful form. It's clean, producing no long-lived radioactive waste, and its fuel source, derived from water, is virtually inexhaustible. The challenge, and it's a colossal one, has always been containment and ignition. How do you hold something that's 100 million degrees Celsius? You can't just put it in a metal box. It would vaporize instantly. The American approach at the National Ignition Facility uses an ingenious method. They take a tiny pellet, smaller than a peppercorn, containing the hydrogen fuel. Then, they fire 192 of the world's most powerful lasers at it, all converging on that single point. This creates an implosion, a shockwave that compresses and heats the fuel to the mind-boggling conditions needed for fusion to begin. For a brief, fleeting moment, they create a star in a laboratory. For the first time, this process has achieved net energy gain. More energy came out of the fusion reaction than was delivered by the lasers to start it. This is the holy grail that scientists have been chasing for over half a century. It's a proof of concept that changes the game entirely. It tells the world that a commercial fusion power plant is no longer a question of if, but when. The engineering hurdles are still immense. We need to be able to do this repeatedly, efficiently, and on a massive scale. But the fundamental physics, the cosmic secret, has now been unlocked. America hasn't just lit a candle, it has shown it can capture lightning in a bottle. While America looks to the stars for power, Germany is mastering the forces of our own planet's atmosphere. Imagine an orchestra of wind turbines, thousands of them, all spinning in perfect harmony to conduct the power of the wind. This isn't a metaphor, it's the reality of Germany's latest achievement in renewable energy. They have just completed the largest single wind project in history, a colossal network of offshore and onshore turbines capable of generating a staggering 14 gigawatts of electricity. To put that in perspective, that's enough power to supply millions of homes, equivalent to the output of more than a dozen large conventional power plants. This project is a masterclass in engineering and ambition. The offshore component is particularly awe-inspiring. These aren't the turbines you might see on a hillside. These are titans of steel, standing hundreds of meters tall in the harsh environment of the North Sea. Building them requires specialized ships, deep-sea foundations, and miles upon miles of undersea cables to bring the power back to shore. It's a testament to human ingenuity, pushing the boundaries of what's possible in our quest to harness the natural, kinetic energy of our world. Germany's Energiewende, or energy transition, is banking heavily on this technology as a cornerstone of its carbon-neutral future. What makes this so significant is the scale. We've known wind power works for centuries, from windmills grinding grain to early turbines. But moving from a supplementary power source to a primary one requires this kind of massive, coordinated effort. It demonstrates that with political will and technological investment, renewables can become the backbone of a modern industrial economy. Germany is not just building turbines. It's building a blueprint for how other nations can transition away from fossil fuels by capturing the immense invisible river of energy that is constantly flowing in the air all around us. Now let's journey from the sky to deep beneath the Earth's surface, to a concept that feels both futuristic and ancient. One of the biggest challenges with renewables like wind and solar is intermittency. The sun doesn't always shine, and the wind doesn't always blow. So how do you store that energy for when you need it? In the Swiss Alps, engineers have unveiled a breathtaking solution: a massive water battery. It's an energy vault designed to store power not for hours or days, but potentially for seasons, using the most fundamental force in the universe: gravity. Here's how this elegant piece of cosmic clockwork functions. The facility consists of 2 large reservoirs of water, located at different altitudes. When there's a surplus of energy on the grid, say on a particularly windy or sunny day, that excess power is used to pump water from the lower reservoir to the upper one, which is nestled high in the mountains. This process effectively converts electrical energy into gravitational potential energy. The water, now held in the upper reservoir, is like a massive 200 million ton weight held aloft, a giant battery waiting to be discharged. When the grid needs power back, the process is simply reversed. Valves are opened, and the water from the upper reservoir flows down through massive underground tunnels, spinning turbines along the way to generate electricity before emptying into the lower reservoir. It's a beautifully simple, incredibly powerful system. This particular plant, Nanotech, can store the equivalent energy of 400,000 electric car batteries and can provide stable power for thousands of years with minimal degradation. It's a permanent geological scale solution to a modern technological problem, reminding us that sometimes the most powerful ideas are the ones that work in harmony with the laws of physics. Our quest for resources often feels confined to our own small blue planet. But what if I told you that the universe is awash with the single most critical ingredient for life as we know it? Astronomers, pointing their telescopes toward a distant quasar, an incredibly luminous and energetic galactic core, have made a discovery of truly cosmic proportions. They have detected the largest and most distant reservoir of water ever found. It's a colossal cloud of water vapor, surrounding the quasar, containing an almost unimaginable amount of H2O. Let's try to wrap our minds around the scale here, because the numbers are astronomical. This reservoir holds 140 trillion times the volume of all of Earth's oceans combined. That's not a typo. 140 trillion. This water exists in a gaseous state, spread over a vast region of space hundreds of light years across, and it's ancient, dating back to a time when the universe was only 1.6 billion years old. Finding such a vast quantity of water from so early in cosmic history provides profound insights into the formation of early galaxies. It tells us that the essential ingredients for life were present in the universe from very early on. While we can't exactly pipe this water back to Earth, the discovery is deeply significant. It confirms that water, far from being a uniquely terrestrial commodity, is a common and abundant molecule throughout the cosmos. It suggests that the conditions necessary for life could be widespread. As we look to the stars, not just for energy, but for our future as a species, knowing that the universe is filled with this life-giving substance is a source of profound wonder and optimism. It reshapes our understanding of our place in the cosmos and hints at the untold possibilities waiting to be discovered among the stars. Let's bring our journey back to Earth and back to the challenge of fusion energy. Remember that problem of containment? How do you build a vessel that can withstand temperatures hotter than the sun? Even with magnetic fields holding the superheated plasma, the inner walls of a fusion reactor are still bombarded with intense heat and radiation. Over time, the metal walls weaken, become brittle, and eventually fail. This material degradation has been a major roadblock to building a fusion power plant that can run continuously for years on end. But now, scientists at MIT have devised a brilliant solution, using technology on the smallest of scales. Their breakthrough involves strengthening the reactor walls with ceramic nanoparticles. Think of it as creating a kind of high-tech, nanoscopic armor for the reactor's interior. They've developed a new type of steel alloy that is infused with these tiny ceramic particles. These particles are incredibly stable and act like microscopic anchors within the metal's structure. When the material is exposed to the extreme conditions inside the reactor, these nanoparticles prevent the atoms in the steel from dislocating and forming cracks. They effectively pin the material's microstructure in place, dramatically increasing its strength and resistance to radiation damage. The results are nothing short of revolutionary. This new nanostructured steel is significantly more robust and has a much longer lifespan than conventional materials, potentially allowing a fusion reactor to operate for its entire functional life without needing its core components replaced. This doesn't just make fusion power more reliable, it makes it vastly more economical. By solving this critical material science problem, the team at MIT has removed one of the last major engineering barriers standing between the promise of fusion and a commercially viable power plant. It's a perfect example of how the biggest breakthroughs often come from manipulating the universe at its smallest, most fundamental level. We've journeyed from the core of a man-made star to the windswept seas of Germany, from deep within the Alps to the farthest reaches of the cosmos. Each of these breakthroughs, whether it's achieving fusion ignition, building colossal wind farms, or designing nanotech armor, is a powerful chord in the symphony of human ingenuity. We are living in a pivotal moment, a global race not against each other, but against time. A race to transition our entire civilization to a sustainable energy future, to power our world without poisoning it, and to secure a future for generations to come. These stories are more than just scientific headlines. They are beacons of hope. They show us that the challenges we face, as immense as they seem, are not insurmountable. The same curiosity that drives us to find water 12 billion light-years away is the same curiosity that is solving the puzzle of fusion here on Earth. The same engineering prowess that allows us to build mountains of steel in the ocean is the same prowess that lets us store energy within actual mountains. The solutions are all around us and within us, waiting to be discovered and unleashed. The path forward is clear. It requires investment, collaboration, and a shared belief in the power of science and technology to uplift all of humanity. From the cosmic to the nanoscopic, we are learning to master the fundamental forces of the universe. The promise of a clean, abundant, and bright future is not a distant dream. As these breakthroughs show, we are actively building it, piece by piece, right now. The stars are not just something to gaze at in wonder. We are learning to bring their power home. Keep looking up.